I'm so confused.
I am too.
Whoa.
Whoa. Oh no.
Wait, so is A already done for us?
I don't like chunky cheese.
She says that?
For number 4? No, we have to
You
draw.
have to continue.
Yeah, you have to continue the graph. Yep.
She says
Oh,
weird stuff like that?
Yeah, all the time.
Shh. Quiet.
I just really should. I just doesn't.
Shh.
You have to write it on the back of the answer sheet. It's a constructed response, just like Hannah's doing right here. Excellent. Because this up here is per kernel. The pressure of 9.2 atmospheres is the theoretical. So we're seeing how close we're going to get to that. Now they said a temperature of 225 in the book, and then they said a mass of water. I got 2 yesterday, so we'll do 1 in this period and 1 next period. So I got 314 was the mass of the water that was emitted. That's pretty high. That's a lot of water. So we divide that by 20, so they're saying around 0.157 grams of water is released per kernel. That's a lot. Now let's set up our problem. So we have P we're solving for equals nRT over V. So P equals, now we need to convert into grams. So we've got 0.157 grams H2O times 1 mole H2O is going to be 18 grams mole H2O. Alright, so this is going to end up being, let's divide that out, variables. We were given 1 kernel is going to be equivalent to 0.157 grams of water given off on our first example. We've converted that to 0.00872 moles of H2O from the periodic table mass, divided that by to get it in mole. Temperature had to be in Kelvin, so we had 273, got 498 K. The volume has to be in liters because our R is in liters. The units have to be the same, so it has to be liters, mole, Kelvin. So we have our Kelvin. So we took 0.14 divided by 1,000, we got 0.00014. So then we want to come over here and set this up and see what we get. This is going to be 0.00872 mole. And then temperature is going to be 498 K divided by, stack over there, 0.00014 liters. Now let's solve that here and use their calculator and solve for the P. If they get the right answer and the right pressure, they get a bonus of 10 points on their lab. Right. So now what we want to do is we want to take our actual divided by the theoretical and see what our error is. So we take that divided by 9.2. Take the percent error, we take the error equals the experiment value minus the accepted value. And the percent error equals the error divided by the accepted value times 100. So we have that right up here. So we have the error divided by the accepted value times 100. What's the answer again? 27,573.9% error. Now, I do want you to be aware that percents can get relatively large, especially if you're following the stock market, because sometimes stocks can have these huge percent gains. You're like, that stock had a 500% gain. So I don't want you to think, that percents can't get really high, which they can. I've heard of stocks having a 16,000% gain. When you want to invest in that, amazing. Well, the water coming off of the popcorn, our values are a little bit high here. So if you take a look at that, the difference between these two, you see how the error drops. So it should not have been that large of a difference, because there is some water in the popcorn, but we shouldn't have noticed. 1.56 grams is even a lot. It should have been closer, probably to around 0.4 or 0.5 grams. Get a good grade. Then I'm gonna give you an opportunity for some extra credit. No? Cross out what's there.
Okay, so
I'll give you a hint. See how the leader crosses out there and there?
yeah.
So there's two, cross them out and you'll be left with the right one.
Oh.
No. Because you see a mole here, you see a mole there.
Ah.
What's left?
There's nothing left.
Yes, there is. It's right in front of you. Gonna bite you.
P, the word?
No.
$1.25.
Starts with the A.
ATM.
Yes. The oil right here, 225. So we got to take that, add 273, gives us 498. Now, I had more than one mass of the water that was released when we popped the popcorn. I had 3.14 and I had 1.56. So let's take a look at the 1.56 here. So we're going to put that value right here. So we get a different value here. Comes off the water that's lost, the mass that's lost. So it's around 0.043 moles of H2O from the kernel. That's the mass of the water that's lost. The volume of the popcorn, I got around 2.8 divided by 20. That's about a tenth of a milliliter. So if you look at the popcorn that we had yesterday, kernel, we can see that it's approximately a centimeter in length. Looks like it's about a little over half a centimeter in width. And then I guess it's height. So we got our length, width. Width is about, we said about 1/6, and then the height is going to be hard to measure because of it like that, so we'll just go on the side there. Looks like it's a little less, or close to half a centimeter. So we average that out to be around 0.5 times 0.5 times 1, around 0.25 approximately. So we're just changing that value a little bit to see what we come up with. I'll give you 10 points extra credit.
ATM?
Yes. So 70 ATM. Now is that pretty good? Well, let's take a look at our error. So the error is, at our error here. So we have the error equals the experimental value minus the accepted value, 70.8 minus 9.2. And then we're going to take our percent error, means the error divided by the accepted value times 100. So we can see, you know, how good we are. What'd you get? What'd you get? Yeah, 669% error. So that's kind of a lot of error. You have 600% error. Now I want you to be aware of that. That can happen. Where is most of our air coming from? Probably from the water that's coming off. Steam doesn't really often produce a lot of water. When you condense it, you'll see that. So I think we have an 1.56 grams of steam coming off there. The corn up here, if I place the corn on the balance, where did my corn go? It was by the, did I lose my corn? Well, let's just take a piece of corn off here out of this container, and I'll just dry it off a little bit, best that I can, and I'll place it on the balance. The corn only weighs 0.25 grams, so the water coming off of this one is 0.078, right? So that's, I mean, let's take a look at how much of that is. You could take 0.078 divided by 0.25, it'll tell you the percentage. The air, most of the air is coming from the water, because if the corn weighs around 0.25, all right, we had a piece of kernel here, and it's around 0.25, and the water coming off is per kernel 0.078 subtracted 2, you get 0.72. And you divide that by your original, you end up getting around 70% corn. So that'd be 30% water. It seems like a lot. Josh, it's because of you that you don't get the curve, because you were talking. I got it on video.
Wait, so you use
You can use pen. It will scan it.
Wait, it won't.
May I have a pen?
You can use pen or pencil.
May I have a pen?
I prefer pen because you can't erase.
Is there actually a short answer?
Yes, number 4. Write it on the back of the Scantron.
That's what I got. I got to write it back.
That's wrong.
That's wrong?
Well, you got to give me the final answer.
Well, yeah, I got to.
Can you just take it with me?
Why is it staying the same at 50 or 60?
Because it's getting ready to change state. Like to go from a liquid to a gas, it takes energy to do that, so it'll take a little bit of time.
So when it goes to a gas, does it just go higher?
Yeah, when it starts to go into gas, the temperature rises.
What does this kid have in his class?